Uh, so let's talk about software security and mostly preventing hackers from taking advantage of our software to use it for something other than its intended purpose, usually something malicious, usually something that hurts our other users or ourselves. And these hackers, anything that's available, any possible way to get in, a dedicated enough hacker is going to get in. But fortunately, most hackers are a little too lazy for your apps that have very small scope, very small user bases. Like it's not something we rely on. We cannot rely on this. But for a lot of your apps, like nobody's going to be attacking it except maybe Dr. Hertz or myself, um, but or your PM. So most people are too lazy. Like our students, there can be some vulnerabilities in our courses, but some students are, if they're too lazy to actually complete the assignment itself, usually they're too lazy to take advantage of those things. That said, we still try to plug up any possible vulnerability that we've had. I've had some in my classes in the past. Only the top students found them, but they'd find them and then tell me like, "Hey, you have this vulnerability," which I super appreciate. Um, but um, but we don't want them to be able to break things. I didn't want to spend that much time on that slide. So in security, I don't want to dwell on this too much, but you hear it in the news. It's always in the news where something gets hacked. PSN gets hacked. It seems regularly, at least twice now. I think it was. We had the big. Oh man, I forgot the name. Not Experian. The big credit score company. Man, I'm blanking on the name. Uh, anyway, that big hack that happened just a few years ago, that released financial Equifax. That's the one. Thank you, Ruslan. Thank you, Lana. And millions, hundreds of millions of people's financial information was leaked, including social security numbers and all kinds of sensitive information. No good stuff. So this happens all the time. We have vulnerabilities. Sometimes even when vulnerabilities are known, it's tough to patch them and fix them. Drupal, an example, had a SQL injection attack, and then even after they patched it, attackers who already took advantage of the injection attack to insert their backdoors into the software, the patch didn't fix those backdoors. It didn't go in and actively remove the backdoors that attackers injected. It only prevented more injection attacks. So it was this huge fiasco. They had to do quite a bit of work um, to finally get past the bug. I assume they're over it now, but starting at 2014, 2019, they're still talking about this exploit. So it's can be bad, I guess is the moral there. It's very hard to recover after you release vulnerable software. What is your proposed solution to social security numbers? Yeah. Um, yeah, if you're gonna, that's one of my general rules in life. If you're gonna criticize something, you better at least have a better solution than the one that's already being used. So I appreciate that kid from the city. If you have a better idea, the world can benefit from your idea. Please share. But if you don't, like, what else are we supposed to do? Uh, and remember, even when you don't have malicious attackers like just trying to steal people's information, just remember some people are just jerks. Like some people will just try to attack your site just to break stuff. Like they might not even have an objective. They might just be trying to break it. And hell, I'll be honest, I've tried to do this before. Not really maliciously, not to really destroy anything, but just to see if I could, like just to see if I can break a site, and then I would stop short of actually breaking anything, of course. Um, but just seeing if you can break things, I don't know, it can be fun. So if your site's vulnerable and you have, say, a bored computer science student, like any of my grading sites and Autolab and all that, at some point there have been bored computer science students who will try to break it just for fun. And like I said, sometimes they'll report back the results. Possibly all the time, but hey, if they don't report the results, how am I supposed to know about it? Maybe they're taking advantage of things right now that I just don't know about. It's possible. Uh, yeah, ethical, and we can talk about the difference between black hat and white hat. But if you're trying to find the vulnerabilities and then letting people know, that's the students I'm referring to. They would be white hat hackers, to use the terminology, where they look for vulnerabilities just to improve the security of sites in general. But there are the malicious ones. And a recurring theme throughout these lectures, once hacking becomes a game, you're going to lose. You have to completely prevent any possibility of a hacker getting in to be able to win. That's the only way you win. As soon as it's a game, as soon as there's some back and forth and some kind of arms race, the hacker's going to win, because there's going to be a hacker. As long as they're interested in hacking you, they're going to win. So you don't want to rely your site security on, well, maybe nobody will feel like breaking my stuff. They're going to win once they're interested, because there's going to be some hacker with way more time on their hands than you, and they're going to win. You have to absolutely just lock everything down and not allow any chance for them to get into your system. The universe will not exist after hacking. 256 bits. True words. True words. If you have true entropy, is pretty critical. That's something I don't know. Maybe we're talking about security all week, so maybe Wednesday I can talk more about entropy and stuff. And we're mostly talking about web code. So security, it's usually prefaced with the word cybersecurity. If you're not connected to the internet, I won't say security isn't an issue, but it's less of an issue. Once you're connected to the internet, and now anybody on the planet can try to attack your software, well, now you have to be concerned. If you're making a web app and you're not thinking security, you're just asking to get hacked. It's going to be a bad time at some point. You have to be thinking about this if you're building web apps. So once we have a web app, we better be concerned about this. And yeah, most web apps have at least some security flaw in them. I'd say it's rare to find a completely secure site. Maybe the big sites that you visit, the major sites, the Googles and the Microsofts, might not have vulnerabilities, at least not obvious ones. Maybe somebody with access to the source code and tons of time could get in there. But the lesser known sites, hell, I'll even say probably the software we use for courses probably has some vulnerability in it somewhere. I wouldn't be surprised. I'd be surprised if it didn't. But if a really good cybersecurity expert couldn't find a way in, I'd be shocked. I'd be happy, but I'd be shocked. Are we gonna the last question this? What does that mean? And a lot of web apps and even mobile apps, the way Dr. Hertz structures the slide, he wants to blame JavaScript, and I don't even blame him. JavaScript is pretty evil. But in general, any UI that your customers have, your clients, that your users have access to. So not just JavaScript for web-based apps, but if you have a mobile app, your users still have the code for that app. That code is downloaded and running on their machine. So they have access on their device. So they have access to all of the code for the front end of your site. So this is going to create huge concerns for us. And in general, the TLDR of it is never, ever trust your front end. Assume that your front end is completely compromised, because it is. Your front end is compromised. All your security has to come from the server side, the code that your clients don't have access to. I gotta take a quick breather here. Okay, an infrastructure for security, a secure infrastructure. You'd be a billionaire, sure. You absolutely would. So one of the big things that we rely on for web security is this little letter S. That is an important letter. So HTTP is unencrypted. It is just a protocol for web communication, to be able to request information from a website or send information to a website, a web service, or an API. HTTPS is doing the same exact thing except encrypted. This is very important. It's easy for hackers, or really anyone, to just listen into your web traffic. If it's not encrypted, they can see exactly what you're doing on the internet. That's a huge security risk. That's why pretty much everything is HTTPS right now. It's very hard. I try for examples in lectures, I try to find sites that are HTTP still without the S, without encryption. And each semester, the examples that I had from the previous semester are encrypted, and I have to go and look for new ones. And I've gotten to the point where I can't even find HTTP sites. Maybe I could with a lot of effort, but the internet's pretty HTTPS right now. Chrome had this big push a while back now, where if you were still running HTTP on your server, they gave all kinds of warnings. If you go to an HTTP site, they have all kinds of warnings to say, hey, this isn't encrypted, watch out, watch what you do. So once Google did that, it really pushed every app developer, every web developer to add that S, get their certs installed, and encrypt their traffic, which is honestly super easy to do. There's no reason not to be HTTPS, to be secure, to be encrypted. If you're not encrypted, you might say, well, somebody has to eavesdrop on that communication. They might have to hook into a router or something and be able to capture my web packets and stuff. No, not at all. They just have to be in range of your Wi-Fi. They can pull the packets right out of the air. Anybody can do this. When you're on campus, especially any public place, any public network, doesn't even have to be I guess it would have to be a public network. But any public network like campus, back when we used to go there still, anybody within range of that Wi-Fi, so anybody in that lecture hall with you can pull your traffic right out of the air and see what you're doing. If it's HTTP, they can see what you're doing. If it's encrypted, they can still see what sites you're going to. So I always give the example, if I ever become a really grumpy old professor and I get a bit unethical, to be honest, what I could do is sniff packets during lecture and see if students are like going to YouTube in the middle of lecture or social media or whatever. You can still see which sites people are accessing unless they use a VPN. And this is why even while all the most web traffic is encrypted these days, this is why VPNs are still so popular, because that can give you that extra layer of privacy as you're browsing the internet. So if you're on a public network, HTTPS and VPN, if you don't want people knowing what you're up to. But if you're just going to like UB Learns and course websites, who cares? But that's what you're supposed to be doing anyway. And these are both stateless protocols. This means that if you send two HTTP requests or HTTPS, I usually just say HTTP because I'm lazy, I don't want to say an extra letter. But if you send two HTTP requests to the same server, that server will not remember you. This is a stateless protocol, and every request should be handled in complete isolation of any other requests. Does incognito provide any sort of protection? No, not really. I mean, it might. I never looked too deep into incognito if it sets some certain flags that says the do not track flag. I don't think it does. But incognito is mostly used for if you're using the same machine as somebody else, like if you're sharing a computer with your family members, it prevents them from seeing what you did on that computer. That's what incognito mode does. It's not meant to protect you from sites from the outside world itself. Just people who use that same, maybe you're sharing a laptop, use the same laptop, they can't see your history, your browsing history. Of ARP spoofing? I'm not even sure what that is. Beefy Indian Kid. ARP. I'm not sure what that is. What's ARP? It removes local data. Yeah, I would guess that it does also remove like your man, I'm blanking today on a few things. Do we do a demo of that? We could find out. I'll do it after lecture if somebody reminds me, if I remember. To see if it removes local data. I would expect it to, but I've never checked personally. So we could run a live demo and see if it does. So these are stateless protocols. So we have to get creative because we want state in the modern internet. Address resolution protocol. Oh yeah, that sounds interesting. It sounds super interesting actually, but I'm not familiar with that specific attack. Beefy Indian Kid. Yeah, that sounds neat. Yeah, just pretend to be a different IP address. It could be interesting. But no, I'm not familiar with it myself. Should only be that should only be relevant on a LAN, but UB's network is a LAN. So it's a stateless protocol, but we want state in our web traffic. The most common example of this is logging into a website. Once I type in my username and password, I expect to not have to type that in for every request. Every time I click, every time I want to look at an image or anything, I don't want to have to re-authenticate. So we need ways to be able to use this stateless protocol, which was designed before we really thought about authentication and things like that. So we want to use a stateless protocol, but kind of add state to it. And we do that with cookies, but I guess I'll talk about get and post first. So there's two major ways to access web content. These are the two, let's say, most popular, most common ways. Get and post. Get is when you just want to get information from a website. Post is when you want to send information to a website. So the difference between a postcard and a letter with some enclosed information. So we want to have the kind of illusion of state in our web apps, which you have the illusion of state as a user. You kind of feel like this is a stateful protocol where the website remembers you. So we do this, primarily through cookies. So we have cookies. That is information that travels along with your get and post requests to that server. So maybe you log into a server. That server is going to set some cookies that identify you and identify that you have been logged in. And then whenever you send subsequent requests, you're sending those cookies along with your request. So the server doesn't remember you across HTTP requests, but it reads those cookies, verifies those cookies, and says, oh, you have this cookie, you must be so-and-so. You must have authenticated at some time in the past, or else there's no way you would have been able to access, you never would have gotten this cookie, because this cookie is also in my database, and it tells me that that's you're the one I gave this cookie to. So you must be that person. This is why your favorite social media site, you probably logged in once and then never again until you switch browsers or you manually delete your cookies. You're not logging in again. You're not re-authenticating. And they don't want you to, because they don't want you to have any reason to not revisit the site. They're going to make it as easy as possible. So these cookies are stored on your computer, and they allow you to kind of have this illusion of state over HTTP requests. These cookies have key value pairs, a name and a value, and then some additional attributes which are optional. We can have extra information attached to a cookie. There are many different types of cookies. I don't want to go through all of these. Which one do I want to? So session cookie is short-term cookies. If you go to a site but you don't authenticate, but they also want to track you across that site visit, they'll send you a short-term cookie. Long-term, if they want to remember you longer. Some cookies are only sent over HTTPS. These secure cookies, if the secure flag is set. Third-party cookies are the ones we don't necessarily like. I guess I am just going through all these. Third-party cookies, we don't, personally, I don't like these, but these are used for tracking purposes, usually to track your ads. If you're on one site and you do something and then you go to another site and you get an ad for something that you did on the other site, it's because they were tracking you through a third-party cookie. Or maybe they had something more sophisticated that they did, but most likely they tracked you through a third-party cookie to be able to track your activity across the internet. This is how they can do that. So it's a cookie set by another site. This one frustrates me for one key reason. I like to disable them. So I'm not tracked across sites, but Duo for UB learns, or for UB for authenticating, Duo sets a third-party cookie if you want to be remembered for 7 days. If you don't want to have to go on your phone every time you log in, that's through a third-party cookie that Duo sets when you visit buffalo.edu sites. It has to read that Duo cookie. So this one frustrates me because I have one reason that I use all the time that I have to allow third-party cookies on at least one site. Frustrating. But they couldn't, add that to buffalo.edu and treat it as a first-party cookie. But anyway, HTTP only. This is important to limit the ways that cookie can be interacted with through JavaScript. This will limit the way, like, a user can't just run some JavaScript. Like, you can open up the browser console on your browser and run any JavaScript that you can think of, that you can type. And this prevents you from, or limits you rather, from setting cookies through your JavaScript. So this effectively means that only the server is going to be able to set those cookies. It's not fail-safe, just like anything. It's not fail-safe. This is enforced by your browser. If you're using a browser that doesn't enforce this, or you open up your IDE and custom write your own HTTP requests, you don't have to follow this. It's just built into the browser, so any major browser is going to respect this, but it's not a fail-safe. Same with a secure cookie. The server's not going to send you a secure cookie over HTTP, but there's nothing stopping you from breaking that. In that case, why would you do that? Because you're just exposing your own information. For the HTTP-only cookie, if you have HTTP-only authentication cookies that you stole off of somebody else's laptop and copied into your browser, you can't really do that with a major browser, but if you have your own browser or your own code, guess what? You can set those cookies. And then same site cookies that avoid this cross-site request forgery, meaning that you try to send a request from one site to another site. So if I have an attack site set up and I have some JavaScript that says, make this request to google.com, and then I read the response to that request and read the cookies from that response on my server, I can't get those cookies because Google's not going to send those cookies to my attack site. So that's another important layer of security. My phone listens to me every time I talk. I hear so many stories about this. It's, I try not to be a conspiracy theorist, but there's so much anecdotal evidence for this. I wonder if anybody's done a legit study where your phone listens and then you see ads about it. I mean, I'm in the camp that it's probably just coincidence, but man, I hear so many stories. Yeah, and with Alexa and Google, you shouldn't be surprised. I have Alexa in my house, so I'm not surprised if she listens. And I don't want to go into too much detail in here, but you can narrow the scope of cookies to certain domains, subdomains, or paths to limit when the cookies are going to be sent over the internet. So, like, if I have a site on Cheshire and I want to set a cookie, and somebody else has a site over on maybe Fury, if I have a fury.cc.buffalo.edu site, and you don't want me having access to your cookies for your page, you can limit the scope of those cookies to just your subdomain. So when they're visiting my Fury site, their browser isn't sending your cookies to me, so I can't mess around with your stuff. So if you don't trust everybody on your domain, which you shouldn't with buffalo.edu, a lot of people have access to that domain, then you can restrict access to those cookies. Same with pages within your own subdomain, or if you have a slash, a lot of you are on this server, but you have your own path, you might want to restrict those cookies just to your path, so every team in this class doesn't have access to your cookies once you're deployed. I know, I as it came out of my mouth, Lana, I'm like, oh my goodness, I just personified a robot. But it's it's the future. It's kind of scary, but and you can go to your cookies. You can go in your browser and look at all the cookies. And I kind of want to there's no way I'm getting through these slides, but maybe after the lecture, official lecture time, I'll go into the browser and show some demos of messing around with cookies. Yeah, we're only on 19 out of 3 times that. And of course, a lot of benefits of cookies or disadvantages of cookies, depending on how you look at it. Some people like personalized ads. I was surprised how popular that opinion was. I started asking 199 students who would have activities about it. Surprised how many of them are like, you know what? I'm gonna see ads anyway. If you're gonna show me ads that are more likely to be something I want, so be it. So I don't know. I don't share that sentiment, but I respect that some people do actually like being tracked on the internet. Not for me, but all right, let me try to get through some of this because I mentioned it a lot just because I like talking about this stuff. I mentioned a lot of this stuff. Here's some PHP code which actually creates and reads cookies. So if you're not using PHP, somewhere in the documentation for your specific framework, whatever web framework you're working with, is going to have some way to mess with cookies. So look up the documentation for yours. You're going to have some way to check if a cookie exists, and if a cookie exists, reading its value. So this cookie is going to check this cookie named SSID. We're going to check if it exists, if it's not, or check if it doesn't exist, rather. If it doesn't exist, we're going to check, wait, I thought I had this. I missed that. So if it doesn't exist or the value of that cookie does not match what we have in the database, then something's fishy, something's going on here. We don't want to give any information to this user because that user might have set this cookie by themselves. They might have just tried to guess something happened. We don't want to give this user anything. So we're going to redirect them to the login page by setting a header, set the location header, and then return a 301 response to them. If the cookie does exist, what is this example? If it does exist, why are we writing it? Maybe this is the login page itself and we're redirecting back to login. But here's an example of setting cookies. If we want to set this user's ID to their name, set their shoe size, or delete a cookie by setting it to an empty value. We can do that by setting these cookies. Set the name, value, key value pairs for these. And we have optional parameters. We can set the domain and the path if we want to limit the scope. We can also set an expiration time for these. If we want the cookie to be deleted after a certain amount of time, we can set the time, and then the browser, after that amount of time has passed, is going to delete that cookie and remove that cookie. If we don't have time, or we do a time of 0, that cookie is going to last forever or until the client or browser deletes that cookie. And we can also set our flags if we want to limit to HTTPS, or limit to same site, or limit to HTTP only. We can set those flags as well. In your web framework is going to have some utility to be able to do that. Read the documentation, that'll say exactly how to set secure only, same site only, HTTP only. And we have a lot of really bad things that you can do that will open up vulnerabilities to the script kiddies, the people who call themselves hackers but don't really know how to hack. You don't want them to be able to attack you. And there's quite a few ways, we'll go over 5 of them, where you can open yourself up to vulnerabilities like that. Misconfiguration, this was the Equifax attack, is where you just don't configure things properly. A lot of software out there is going to come with default passwords for the admin account, and you have to change those passwords immediately. From what I understand, the Equifax account, they just didn't change those default passwords, and some developer at some point was like, just curious, and said, I think I'm going to try to log into this with the default username and password, and lo and behold, they gained access. And I believe they even contacted Equifax and said, hey, you got to update your dang passwords. Like, what are you doing? This is crazy. They didn't do anything, and then finally the person felt obliged to, obligated to release this information. I'm fuzzy on the details, but I believe that was the issue, was they just were using known software and didn't change the default passwords. Hundreds of millions of people, financial information out there, just because the thing was misconfigured. Don't be that person. Don't be that developer. If the source code is visible, this, of course, you could have like your code in a public repo or something. People can scour the source code. More to the point, though, or more commonly, I should say, is the front end of your app. All of the code for that is visible. You can open up the browser console and you can see all of the HTML, CSS, and JavaScript for the page that you're visiting. All of that code is sent. You send that code to your client's machine, to their browser, and then the browser runs that code on their machine. Well, if it's on their machine, they have access to it. They can change anything. They can change any of your HTML, CSS, and JavaScript. Any of it. You cannot trust it. They can also look for vulnerabilities, or they can just look at how your site's used, and just gain information. They can look through your JavaScript and figure out how you're accessing your API endpoints. They can start reverse engineering that and figuring out what they can do to try to attack that. So it's not just like having your code leaked or something. It's the code that you're explicitly sending your users for the intended purpose of being able to use that app. Most importantly, your JavaScript that you're sending over to the client. Or if you have a mobile app, any of the code, like they download and install the front end, not your server-side code, but the front end of that app onto their device. They have access to that code. Now, that might be compiled into machine code, possibly, but that could also be decompiled. That can be read by a sophisticated enough attacker, by a sophisticated enough engineer, or they can even just sniff their own packets. They can look at the communication between your server and the client and start manipulating those requests, because they can just write their own post requests getting post requests and HTTP requests in general to your API, to your backend, to your server. So that's got to be taken into consideration that for a web app, they explicitly have the client-side code for your app. Any client going along with that, the client-side controls, if there's any important logic happening on the client side, you're wrong. Like doing something like this, checking for their admin role in the JavaScript that you're sending them. In any JavaScript, unless you're using Node.js and have server-side JavaScript. If you have client-side JavaScript and you're like checking for admin role and allowing access based on that check, no. Because if I'm trying to hack this thing, I'm just going to say, I'm going to delete all of this and just replace it with return 1. And that's something I can do because I downloaded your JavaScript code. It's on my computer. You're not going to tell me I can't edit a file that's on my computer, running on my browser. I can change that thing. Never trust your front end. Never, ever, ever trust your front end. If you have something like this, you might think you're being clever. Well, I'm just going to make this form field hidden, and they can't change it now. Well, I'm just going to go into the code and edit whatever this is and change it to admin. Can't trust your front end at all. All security comes from your back end, from your server. You cannot have any security on your front end because that security does not exist. Does not exist. And yeah, like we said earlier, and this creates a game. If you have any security on your front end, it's just a game. The hackers are going to find a way to circumvent your security. It's no good. Don't do it. Your grade should take a hit. Hopefully the grading PM is looking for these things. Because honestly, if you have... This is something I want to do, but it's always tough to do because logistically. But if you have a security issue, a big one that compromises your whole app, I think you should just fail. But the real world doesn't work like that inside a class. The real world does work like that, but inside a course, it's tougher to do that. But you really should fail if you're building a web app and not thinking about security. In CSE 3.12, I think I will actually do that if you have a major security vulnerability. Because if I graduate you go out there in the world and you're building a web app for a company and you don't give a damn about security, you could make the news. You're certainly getting fired. It's not It's not a good thing. So no, none of that. Also, in your cookies, your client can edit your cookies. So if you have a cookie that's saying that you're an admin or a guest, well, guess what I'm going to do if I'm an attacker? I'm just going to change that cookie. I'm going to edit it to say admin. And now I'm an admin. Because that's how you're doing your checks, is by some client-side stuff. By editing something that I have access to. Can't do that. I think that's the same point, right? Oh, just if you're encoding the role. If you're saying, well, if the role is this random string that I came up with, eventually a hacker's going to figure that out. They're going to set that. Isn't bad promo better than no promo? No. I mean, yes, in some cases. Like, there's no such thing as bad press. When it comes with losing your job, at a like an organizational level, maybe. But when it's an individual level and you're losing your job, unless you can monetize that press somehow. Like, if your job is to be a celebrity, like, there's no bad press for a celebrity, because that's their job, is to get people talking about them. For an individual who's not famous, like, how you gonna monopolize on that? How you gonna cash out on being the person who tanked the company they worked for? So don't make it a game. Just don't give any way for them to access your stuff and modify any security stuff. But yeah, if you want that bad press, I mean, I guess. I don't want to hire you if that's what you want to do, though. Yeah, I destroyed that company. Maybe that company's competitor, will hire you for something, but maybe they'll be happy with you, but I don't know. It's not a path I would go down. It's also direct object references. So this is when your client has direct access to some of your data. If you have a database that takes information from the user and directly looks up that information or edits, even more scary, edits or modifies that information without any server-side checks. So the server, any information that you get from the client, you have to authenticate. Yeah, I'm going to edit the string admin. Boop. That's true. I did already hire you. Well, now I'm having second thoughts. I don't know. So, like, if I send this login information and that's directly accessing something on the server, I got to be mindful of that and understand that I can't trust anything from the client. So, for example, if I'm editing my account information on Autolab, guess how that occurs, or how to get to that edit page is a value directly in the URL. Well, if the value is right in the URL and that's how my client's accessing information, what's stopping them from modifying that URL? So if I modify that URL to a different number, to get it as a different user ID, I can edit anybody's information. I can get the edit page, submit that form, and then change that user's information. So this is when we have code which is going to take that and then directly access the database with whatever I was given, whatever the server receives from the client. Bad stuff. Of course, on AutoGrader and on Autolab, you try that, you're going to get permission denied. So we're good there. But if a site's taking that directly and not checking on the server must check that information. It must validate everything you're getting from the client, at least when it comes to sensitive information like that. You can't just take that URL and said, well, you requested this URL, you must have access to it, here it is. The server has to say, okay, you're requesting the edit page for user 249. hey, wait a minute. I'm looking at your cookie, your authentication cookie, your session cookies and everything, and you don't have access to that. No, not letting you do that. That's what the server has to do. You cannot rely on any client-side checks to be able to prevent that. It has to be on the server, because in this case, it's as simple as changing the URL. If you don't have a server-side check there, there's no security here at all. You have to check that on the server side. Same thing, one thing a lot of students I see do is their password authenticator, their password checkers to check the strength of a password is all client-side JavaScript. Well, you just bypass all that client-side JavaScript and you can send just the character A as your password. You can check it client-side, that's fine, but you also have to check it on the server then. You have to check it on the server. And the server implied in that, but the server must keep the client state as well to check that database. Take those cookies and look up in the database who this client is and what they have access to be able to say permission denied. It's 3 minutes yet. So let's talk about passwords. Use strong passwords is kind of one of the punchlines. But also, when you're a developer, when you have a web app, enforcing strong passwords. If you're letting your users use weak passwords, your users are going to make themselves vulnerable. So it's very easy to brute force a weak password. You can just easily check every possible password until you have one that matches. In 3 minutes, I won't get into the details, but maybe Wednesday or after lecture today, you can just try a bunch of possible combinations and crack that password. But breaking it from a subdomain, sometimes more vulnerable than a main domain. I don't know about that specifically. I'd have to see some examples. Randomized string and URL always secure. Not. Depends what you're securing. Both of those would need more specific examples. Randomized strings in the URL, that's usually to identify like a specific document. Whether those, for authentication, usually those randomized strings are in the cookies, in the authentication cookies. The randomized strings in the URL, I believe they're mostly just randomly generated IDs for specific pages. So like I think of Google Docs. If you create a new Google Doc, you need a URL to access that doc, and that URL has to be unique from every other Google Doc that exists, and that URL has to be constructed programmatically. You're not going to take user input and say, okay, what do you want your document ID to be? Because then you have to do the whole, that one already exists, try again. You have to do that kind of stuff. So they're randomly generated just so they can generate unique IDs for each document programmatically without having the user to care about it. I'm not aware of any site that uses randomized strings in the URL for security purposes. They will also use them for tracking purposes. If you get a link in your email with a random string in it, they're using that to track you. So they know that you clicked the link in that email. They're going to look up the database and say, oh, that's the random string that we sent to this email address. Now they know that you clicked on that email, and you're probably going to get more emails from them. You're going to be put on some sort of list, at least, that email address is. But I'm not familiar with randomized strings in the URL for security. I'd have to get an example, and I'd judge if it's secure, if it adds security or not. So a few things on authentication. Your error messages when somebody logs in, you don't want to give them too much information like this. Your password has changed 4 days ago. You don't want to give that information because now somebody trying to hack that person's account knows that they just changed the password. Like any information they can get can help. You just want to say wrong, maybe not even wrong password, even just password didn't match username. because wrong password might imply that an account with that username exists. Like, you don't want to give any information away about your users to their potential attackers. Never, ever send a password in clear text. I was waiting for this slide because this is one of the most important. Never send or store a password in clear text, in plain text, ever. Like, ever. You need to be using HTTPS. Never send a password over HTTP over the internet, because then anybody in Wi-Fi range of that user now has their password. You can't do it. Make sure it's being encrypted with HTTPS. Before you send it, before you store it in a database, make sure it's hashed and salted at a minimum if you want to add more security, but hash and salt that password before you store it in the database as well. You don't want plain text passwords sitting around anywhere. This is like fundamental 101. This is something you've probably heard, probably something even your non-developer friends might know. I feel like it's everywhere. Maybe I'm just in a developer world where I hear it all the time, but never plain text passwords anywhere. There's a slide in here that maybe I should have even deleted, but I wanted to talk about it. Encrypt before sending. This one. So this is an example of hashing a password before it's sent over the internet. This is something that I won't say I don't recommend it, but it doesn't help at all. Hashing a password before you send it from the front end, from the client. So if I'm entering username and password on a site, I believe this is saying, I don't believe this is, since it's using jQuery, I don't think it's Node.js on the server side. Taking a hash of that before sending over the internet. You have to use HTTPS, but if you're using HTTPS, hashing doesn't help. It doesn't add security. And if you're not using HTTPS, hashing doesn't give you security. The hashing doesn't add anything here. So I wouldn't do this. I wouldn't bother hashing before. Just make sure it's using HTTPS when you're sending that plain text over the password, because you do have to handle plain text passwords at some point. Just don't send them over the internet and don't store them in your database. But when a user first enters their username and password to create an account, you need that plain text password, or you don't need, and get into the nuances of that. Oh, we're at the end of the slides. I can go into some examples. But the hashing doesn't help, and there actually is a reason why I left that slide in, which I want to show you. If somebody wants to shout in chat, or all of you, some site that you expect to be secure. I always like taking an example from the class when I do this, but some site that you expect to be secure in handling your password, username and passwords. And I'll show you something that I think is enlightening. I'll read Beefy Indian Kids posts while you're coming up with some. What about breaking in from a website? So, I read that one. Second order. UB learns. Do you expect UB learns to be secure, or are you just saying that? I don't want to do UB learns because that. So the idea of taking an example from you is that I don't want. Actually, I'll do UB learns and something else. But the idea of taking a Bank of America, I'll do that one. I'll do UB learns and Bank of America. The reason I want to take an example from y'all is I don't want it to look like I set it up beforehand. If I use UB learns, it might look like I set it up beforehand. So UB learns. Why did Facebook Messenger come up? Maybe did I click the wrong button? Is that built into the browser? Is this sidebar always there? Have I never noticed that? So what I'm going to do is inspect the element. Inspect element. This brings up the browser console. This is where I could, I can run any arbitrary JavaScript that I want on your site. Here, just a proof of concept, running console.log. But I could say app dot thing that you think is secure equals whatever I want it to be. I can change anything here. and look at all the source code. I can see everything going on with this site. Lots of stuff you can do here. But what I want to do right now is look at the network traffic. Like it matters. And when I send this form, that password, whatever I type there, is actually being sent in plain text. It's not hashed before it's sent. It's being sent in the post request. I have a post request to shibboleth.buffalo.edu, and the content of that is my username and password, not encrypted, not hashed, just plain text password is being sent over the internet. Hashing on the client side does not help at all. It does not add any security. And I haven't found a site yet that actually hashes or hides that password at all through client-side code. Any site you can put in chat. Maybe someday somebody will come up with one that actually does, but I haven't found one yet. That's over plain text, but don't fear, because this is HTTPS, so it is encrypted. So nobody can read it by sniffing those packets. It has to get to buffalo.edu first, and then it can be decrypted, and then they can do what they need to do with it. So Bank of America. Log in. Sign in. Did I get redirected? Let's do this again. Oh man, where am I? Validated sign on. There it is. HTTPS. Scroll down. Man, where is the post request? Does redirect. Maybe after the redirect. There we go. Holy crap. Did you... Now I'm wondering. Now you got me suspicious. Did you know that this one didn't? That Bank of America actually does hash? Oh my goodness, this might be the first. Might be a first. QRNQB? Well, I'm wondering, did you know that? Oh, did I update the... Oh, and this is the, lecture's officially over. I should mention that, by the way. Wow, look at that. I might have to use this as an example in other lectures and other courses. So I sent this. I somehow got redirected to the same URL. Let's do these other couple first to make the point. I'm actually excited that we found one. Sign in. Sign in. Super fake password. Plain text. What was the other one? American Express? Yeah, American Express. Actually, I think I might know what's happening there. I want to stop preserving the log. Oh, it still preserved my log anyway. Login's probably the one. American Express. Plain text. So yeah, that ODXS. That's actually what I was just going to check, if that's base 64. So let's check this, because that doesn't look like a hash. It looks like base 64 encoding. So I don't think that's hidden at all. I think it's just might be hashed and base 64. Man, I might have the first example. Y'all might have witnessed history here. Bank of America. Novel updates. Yeah, I'll do one more. And of course you can do this on your own if you have your favorite site that you're interested in. And this doesn't mean that they're not secure. I want to make sure the point is clear here. The point here is that hashing client side doesn't add any security. So most sites, I have to say most now, but most sites don't bother. Why would you if it doesn't add security? There's no point. Plain text. There's no reason to. There's no reason to hash. So if you do hash client side, your new password is effectively that hash. So the attacker doesn't actually have to know your password. All they have to know is the hash of your password, because that's what the client's expecting. The server's expecting. Server's expecting that hash, and the server doesn't even know what the original password is. So neither does the attacker care what the original password is. There's just no point. The attacker sniffs out the hash of that password, never cares what the original password was, and just sends that hash whenever they want to log in as you. So no security added. It doesn't help. It's only security through obscurity. It's not real security at all. That's right, Chase. Yeah, I'll do one more. I'll do Chase as well. Just because we had one that failed. Chase. I'll do a couple more just to drive the point home. Because usually any one you pick, I haven't had one that didn't work before. You pick one and then it doesn't work and my point is made. But since we had a fail one, it's kind of interesting. I feel like this didn't refresh my thing. Should be right here, the jump in time. And it isn't. Oh, come on, where was I? No, I don't want to retype that one. That one was long. Hey, there we go. Plain text. Not plain text. So these are encrypted because every one of these, I forgot to keep showing it, but every one of them is going to be HTTPS. So it's still encrypted. Only me and the server can read these things. So we're still secure, but they are plain text. They're plain text, but encrypted. But when the client gets it, they decrypt, and they are handling your plain text password. Because there would be no security added to if they just handled the hash. Because that hash is effectively your password then. It's the same thing. You show what happens when you sign up for an account. I could on like one of my apps, but that happens server side, so it doesn't. Like we can see the information being passed. Like when you create an account, it's the same information. They're gonna get your username and your password twice, which I only typed it in once. It's weird that they duplicated it. But you're gonna type in your password twice, so they get 2 of your copies of your password that they make sure match, and then your username. And then on the server side, they'll hash that password and store that hash, a salted hash of that password in a database along with your username. Next time they get a login for you, they'll take the password that you provide, add the salt, hash it, look up your salted hashed password in the database, and make sure those 2 hashes match. And if those 2 hashes match, then they'll assume that that was your correct password. But they'll never store your plain text password, because they don't want this database full of plain text passwords that gets compromised. So if you watch the news stories of any compromise, so-and-so was hacked, millions of stuff is released, that stuff is never user accounts. Like it never says these many accounts were compromised and now people can log in as these users. Like that's not what the breaches do. Like when PSN was breached, it's not like, whoa, people can now log in as you. Holy crap. They can if you have a weak password, but they can't just by default hack the database and get them all unless the server is storing passwords in plain text. Then that database is a gold mine. You can access everybody's information or everybody's account and do whatever you want. When those news stories hit, it's always so this many social security numbers were leaked, this many credit card numbers were leaked, date of births were leaked. It's that kind of stuff that they can't store in a secure way. They can store it encrypted, but if you store something encrypted that you have to read eventually, you also have to have a decryption key stored. And if somebody hacks the server, they probably hack that decryption key too and can decrypt everything. So you can't store like credit card numbers. You can store them encrypted, but if somebody's able to access that database, they probably got your private key, your decryption key as well. So they just decrypt all the information. Passwords are handled in a different way. The server doesn't ever have to know your actual password. They just have to know that the hashes match, and then they can authenticate you. They never have to like decrypt a password back to plain text like they have to do for a credit card, because they need the credit card numbers so you can buy stuff, so they can send it to Visa or whatever, and say, hey, this credit card is making a purchase. Can I do the FBI FAFSA? I mean, any site except apparently Bank of America, which I want to revisit and see if they actually are hiding any information there. I think FBI has a login. You're going to get me in trouble now. I don't think they're going to have a... I might have to go to FAFSA. I don't think FBI is going to have like this webpage isn't going to get me to the employee webpage, but FAFSA will give me the login for a student to be able to fill out the FAFSA. Login. Open in a new tab. And takes forever. I am student. Something that's not gibberish, so you know I'm not just faking it. Oops, I didn't go to the network tab. Still got it. Super duper. Oops, I missed my E. Super duper fake plain text. So Bank of America, I do want to revisit this. Just because it's so baffling to me. So let me do this again. One, two, three, four, five, six. Oh, I might forgot ID. No, I want to go to login. I'll just do password as the password. Then it gives me a bunch of crap. It's weird that it does this. That I do have to preserve the log. It redirects. It looks like it redirects a couple times. Oh, and it sends me, because it sends me right to the forgot password. Is that? Well, that wouldn't make sense. It has to redirect a few times to get to that forgot password page. Hartloff password. Then after these two validateds, that's where we have to look. Validated. Validated, and the very next thing was my sign on. Oh, right, we already looked at this. And then it redirects to some metrics for some reason. Some third-party site. Sends me over there. Then redirects back to sign on. And then gives me this. Let me think. So this is base 64 encoded something, and it's not ASCII. Yeah, FBI open up. Yeah, y'all get me in trouble with that FBI one. FBI jobs. I almost went there, but FBI jobs might be a whole different server than what the FBI actually uses. Like through their jobs page, you shouldn't be able to access any sensitive information. But I'll do it just for the sake of example. As if it matters. Where was the request for that? GBL? Oh, man, it kept sending requests as I was editing. It sent 3 requests. Oh, there's my password. That's awkward that it sent 3 requests just as I was filling out the form. Or 2 requests as I was filling out the form, and then one when I sent. Probably some super secret FBI stuff. I'm getting out of here before I get arrested. Super secret FBI stuff and how to catch you doing something. What are we doing? It was super late. I'm just messing around with stuff. The topic of today was security, so we're just checking out some things. Oh, speaking of, can I go to Twitch during a Twitch stream? Will y'all allow that? If I go to Twitch, so I'm not logged in. At least I shouldn't. Oops, I am logged in. If I log out, it's not going to end the stream, right? That wouldn't make sense. Right? Can y'all still hear me? Okay. So I'm not logged in now. That was the important part there. And if I go to cookies, I'm going to see a lot of cookies for domains that are not Twitch. So I'm getting a lot of course, Amazon we expect to see since they own Twitch, but a lot of other third-party cookies that presumably are tracking my progress. Even Facebook has their fingers in here. That are presumably tracking my, what I'm doing on Twitch. So when I go to Amazon, when I go to Facebook, when I go to sites that talk to scorecard research and Image World, why is that? I don't know what that is. But when I go to other sites, they're going to see what I did on Twitch and, send me ads. Give me ads based on what I watched on Twitch. So you shouldn't be surprised when you could watch a stream on something and then all of a sudden you get ads for, video games and stuff like that. Because, it's not like they're hiding. It's just a thing that companies do these days. And you can also see what flags they have set. The HTTP only flags, the secure only send this over HTTPS, same site. Of course, most of these are same site none. Because they're third party themselves. Like they can't, these aren't Twitch. The Twitch ones, Amazon, even Facebook isn't. It's weird. Anyway, and you also see my authentication tokens here. Well, you shouldn't anymore, I guess. But if you took all these authentication tokens, if I was still logged in, you could potentially, theoretically at least, copy those tokens into your cookies and then be authenticated as me. Those tokens are how you're authenticated on the internet. And, I remember what else we wanted to do. I want a private window. If you open a private window, so there's no tracking history. I'm not authenticated or anything. So you can see what YouTube shoves in front of somebody that they know nothing about. This is what they want to send them. A Biden ad and, some garbage. And Minecraft, I guess. They think everybody likes Minecraft. That's what the algorithm says. And we wanted to see if this sends personal information. So let's check the request headers. No, they're still sending the user agent. So they're still telling them, they still know that I'm on a Windows 64 machine, 64-bit. They still know I'm using Opera, which these user agents are crazily encoded, but this is going to say that I'm on the Opera browser. So like if I go to I don't even have an example on the top of my head. But anyway, if I go to something that, you know how you go to download something and they'll have the software available, binaries for available in like Windows, Windows, Ubuntu, and OS X. But when you go to the site, it'll just automatically show you the one for your operating system, whatever yours may be. It's because they're reading this user agent, knowing what operating system you have, and then sending you that page directly, so you don't have to say what operating system you're using. So they'll still do that even when I'm incognito. I'm still sending that information. Looks like they don't send a do not track flag. It's really not hiding anything from the server from what I'm seeing here. This is still the same information that I'm sending if I'm not in a, I guess we can compare them, if I'm not in a private window. So request headers. You know, some different things just because we're doing different things. Some of these are different because YouTube is, let me just go to the same exact page. Because some of those were different just because we're using different protocols. This is all HTTP 2 or further H3Q050. I don't even know what that one is, but something new Google's using, I guess. But this is all HTTP 1.1, so we're going to get the same stuff. Let's go to the FAFSA. Make sure requesting the same thing. Request headers. No, there definitely is less. Oh, but that's because I have a cookie set. Accept. And the same user agent. And if I refresh, let's see what this does. Oh, I'm preserving log again. Let me stop preserving log. And now I have a cookie set too. So it's still keeping cookies. Like, it's not doing anything for me. The only thing this does for you is somebody's sharing a computer with you. They can't see what you've done. If you're on a VPN, same server, shouldn't have the same cookies. It would depend on how that VPN does it. I wouldn't think so. I would think that VPN would assign each of you different stuff. The cookies should come from your browser, not the VPN. So you send your request to the VPN, and then that includes your cookies, and then the VPN will forward those cookies for you. And then they should have different IP addresses on their end. Like, your request gets sent from one IP address, and anyone else is getting different IP addresses. You're finding your password in plain text on Bank of America? Yeah, let's go back to that one. So we did this demo, and we learned that incognito does nothing for you, except not track your browser history. But it even set cookies the same. Oh, and what I meant to do going to YouTube, if I watch one video and then open a new, you know what, it's worth doing. But I guess we just did the same proof of concept anyway. So if I go to YouTube, I'm going to get some recommendations, what they think everybody wants to watch, which are actually different than what I just had. So that kind of defeats my example anyway. But let's watch this Minecraft video. Let's watch this Minecraft video. Let's watch this Minecraft video. And let's close that. Let's go to YouTube. And now it's mostly Minecraft videos. Well, not as crazy as I expected. But it's more Minecraft videos than we had at the beginning. And Roblox and Legos, Google knows one thing about me now. Even in an incognito window, Google and YouTube, they know one thing about me. and they want me to vote for Biden, and they're going to show me a bunch of Minecraft and Minecraft related videos. So I'm not getting those other videos that we were seeing earlier. It's just Minecraft. Even though this is an incognito window, cookies are still being tracked across tabs. They're still tracking my user session, even though I'm not logged in. Anything that they know about me, they're going to use. They're going to use that to their advantage. And they're doing that through the cookies, because there's a cookie that's identifying me, and then on their server, they're tracking everything that I watch, and then still treating me like a specific user, because they're using that cookie to track my user session. Then if I close this and then open up a new private window, that should give me a new session, since I'm starting a whole new private browsing experience. And I'll be back to the default, this is what YouTube shows everybody kind of thing. Take it for what it's worth, but still showing Biden ads to, if they don't know anything about you, they're going to show you a Biden ad. And then whatever they think random people who've never used YouTube before want to watch. Yeah, oh, of course it's a paid ad, but there are a lot of people paying for ads. Like, why that one specifically? You can come to your own conclusion. Maybe they just paid more money. Maybe that's who paid the most money. Or geography. It's possible. Well, now that you mention that, so now we're in Eastern Europe. So let's see what YouTube shows people in Eastern Europe. Hopefully not, American political ads. I wouldn't expect. No ad at all. Interesting. Still, American music. And then some other stuff. Apparently chill vibes. They think everybody in Eastern Europe wants to look at. But interesting stuff. What YouTube pushes on different demographics is always interesting. Can be interesting. I'm surprised that apparently they think Asians want to see pop-ups. I'm kind of surprised that oh, and they have to check the cookies. I thought they had to do that in Europe too. But yeah, interesting stuff. And a lot of things you can... what I was saying. I was surprised there's no ad in those other two regions that we just checked. Kind of strange. I expected there to be something there in other regions, but I guess it's only us in America that get bombarded with an ad right off the bat. So how do they collect all this information from everybody and rank them? Ooh, man, that's what makes Google. That's a lot of machine learning, a lot of AI and everything. So they track all the information of all their users. Anybody who's ever visited the site, that all gets fed into their fancy network, their fancy algorithms. And the algorithm decides. The algorithm controls a lot of our lives. And we'll never know how they work. That's all AI stuff. If you're interested in that, study AI. It's really crazy, crazy information. Really interesting stuff. But that's when you hear people saying the algorithm. Well, the algorithm just gets all the data and then decides what you want to watch. Oh, Bank of America. I did want to go back there. So you said you did get this. To show maybe if I try to create a new site, enroll or new account, card or account number, SSN or tax ID number. Oh, if they're not even going to replace that with stars, obviously they're not concerned about security for this. What? Yeah, they are encrypting that. Yeah, I think we might have found one that does client-side security. That's what it's looking like. We're supposed to have different graders for sprints 1 and 2. I think it's the same grader. I think it's supposed to be the same. Sign on v2.go. Sign on v2.js. Some suspicious code here. Yeah, I don't know what to tell you. If the I am hearing that from different groups that the graders are harsh. If you can point to specific things on the rubric that don't reflect what you've done, there's a potential for a conversation there. But if you just feel like they were harsh, because you gotta give me more info. It's weird that what's this variable? Global object not defined. Oh, they're legit doing client-side encryption. Do they know that they don't have to do that? And here they're doing a lot of validation, presumably for passwords, but they should also be doing that on the server side. So hopefully they're doing what they're supposed to there. But the fact that they're encrypting on the client side admittedly has me suspicious that they might not know what they're doing. Or they know what they're doing and they're just a little paranoid and they want the feeling of more security. Well, let's try. If I'm messing with things, maybe I should stop using my real name. So it's an invalid character. These are invalid characters. Yes. Bad class Java. So that's the main point. You have access to all the JavaScript of any site you visit, so you can change it. So when you're developing, you need to understand that you can't trust anything that happens on the client side. You can't trust any of that. So let's try this again without... Oops. Did I cut and paste something else? Cut. That you can't trust anything that your client sends you. You have to verify everything on the server side. I don't know if that did anything when I overwrote that function. It might not have. Will be removed after the demo. Those are the kind of comments you love seeing. Oh boy. Add that to the I don't know if they know what they're doing category. Am I editing the right thing? This might be what I want. 8 to 20. Oh my goodness, it has a max of 20. Sure does. Max length 20. Dun, dun, dun. Here it is. Oh, come on. Yeah, and there's no reason to restrict you to 20. That's another bad sign. I'd say that's strike 3 here. If a developer fails to account for that, then their site gets hacked. That's the problem. That's why this is so important. You as a developer, you need to account for that. You need to account for the fact that your client side can be compromised and will be compromised. Yeah, what advantage? That's my thing. What's the advantage? You don't gain anything. Yeah, I get the idea. That hashing, if you can't afford a cert, back in the days when certs were harder to get, but they can break your, I mean, that's easy to break. And there should be, that's what I was looking for. And then you can brute force the hash. It's just like if somebody compromised the database. So I say, like, the news stories don't say millions of accounts compromised, they can now log in as you. But they can still target individuals. And if they have weak passwords, they can authenticate. It's just not all of the millions. Like, it's not as a flashy headline. If they have to say, well, if you have a weak password and they specifically target you, then they actually can compromise your account. So, that's not as flashy on the top of your news story. But they will say, like, change your password, because that's the practical advice that you need to know. Surprised that last one didn't work. I expected that to work. Wow, there's a lot of client-side stuff. Hopefully they're still also doing it on the server side. Am I missing something because of the resize? Or are these methods just not called on this page? We're back at the top. I feel like we're not making any progress. I want to at least make 1 point. Drive at least 1 point from lecture home here. I don't know if I'll really get there. What I want to do is activate this button with an invalid password and be able to send things. Now I could just send my own HTTP request. I can just build the request from scratch and send it. But that's not as fun. I might have to look elsewhere. I can just blank out the encryption library and send plain text. They're redefining. feel like for how much time I spent here, we gotta at least get something. Let's at least do. I guess I can do the easy thing. Let me go to this button. Enable it. That's not that interesting. I was hoping to get something better. That might be all we're getting today, though. Can we at least do... At the very least, can we at least see what they're doing? And show why it doesn't... but there's an encryption key involved. Check this one out. Oops. If this is the... Alright, let's just see if this works first. No, then if we could inject a debug line into their code. You'll see QRQB. QRNQB. It's not encrypted on Chrome. Is that what do I just need to switch browsers? Here's a long shot. Is rubric is there something different in your URL? I feel like I'm missing a big chunk of source code. Don't tell me they put it in their HTML. I'm not even going to try to parse through minified code. Like somewhere in their source code, this has to exist. Because it's not happening in the HTML, it has to be from the JavaScript, but I'm just not finding it. Oh, wait, here we go. This is something I was looking for earlier. Maybe we can do this. AES online. No, this needs a key, though. I would have to get the key. Because they are using encryption, presumably AES, but they also have JS Encrypt, so they could have a lot of other stuff going on, too. I just don't know where my entry point into this code is. Like, I don't even know where I can... Well, actually, now that I think about it... I was going to say I don't even know where to set a breakpoint, but why don't I just set them all over the place? From bankofamerica.com. Oh, if I log in right here, so this is plain text. Oh, I didn't have to do that in Chrome. Yeah, and that's the .go. I was wondering why it was .js for me and .go for you. Let me go back over here and try that. And that brings me here. Huh, that's strange. Yeah, the screen size is too small. It's hidden in smaller screen sizes. I should have cleared the log first. Let me clear my log first. Do that again. Resize. Where am I? Should be this one. Why is this looking so weird? Form data is in the .go? Oh. Okay. Where are we? In .go. Get some data. There's our plain text password. Well, we found it, but that wasn't as satisfying as I wanted it to be. So how come that other login page... Why would one of them be doing something different? Am I not even going to be able to get back to that other one now? Oh my. Was that like the mobile version? Depends on screen size. And I had the console taking up so much screen that it sent me to the other one. So this is the mobile version. That's why he was asking me if I wanted to use the map. The app, I mean. And then on mobile, they do encrypt it. Am I following their logic right here? My breakpoints. Doesn't call either of those methods. Throw breakpoints all over the place. Why not? Okay. Getting somewhere. So this function was called. I mean, it looks like some AES goodness. Some AES or DES. In that AES, oh yeah, because we're in the AES library, so obviously. AES. How do I get my pretty print back? Yeah, so this is the algorithm. So somewhere in here, I'm going to call it at this, but in here we do have the information of the key in all this data. So we could get the key and then, figure out how to recreate the encryption. But at that point, I don't see any point to it anymore. So we'll call it at that. We got to play around in the library and hopefully that emphasized the point that that you don't trust your front end. Never trust your front end. You just can edit all this stuff and go through here and, delete stuff and just change whatever I want. This function should be mapped to by something, actually. This can't just be a fully anonymous function, can it? This that do crypto. Where's this source? Sign on v2 JS home. So this is the one I wanted. We got there. I mean, I removed the encryption for what it's worth. So if I don't want my password encrypted for some reason, but the encryption doesn't make sense unless they're using the same key on the server, but they're using the same key and giving that key to the client. Like, who cares? AES is symmetric, right? It has to be the same key. It's not like they can have a private key with AES. But anyway, we took away the encryption. I don't know what that really proves. It does prove that we can mess with the code on the client side. We can do whatever we want. We can change things, but yeah, we did get there, whatever there is. So can we get the group eval form for Sprint 2? Oh my goodness, you waited to the last second to say something that I need to do. Yeah, I'll get that up. Not right away. I'm gonna go eat some dinner, but probably tonight I'll put it up. Sprint 2 eval form. Good catch. I wasn't even thinking of that. Alright, but yeah, I'm signing off. I spent way too much time doing that already. I shouldn't have spent that much time because I got stuff to do. But yeah, I'll see everybody. I don't even know what day it is. Monday? See everybody Wednesday. Take care.